This is homework from October 9th, 4.1 practice on arithmetic sequences. Question number 1 asks you to describe the pattern in each sequence, then find the next two terms of the sequence. So part A, if I look at the pattern and I go from 21 to 16, 16 to 11, 11 to 6, I can see that it is going down every time. So my pattern or my common difference is minus 5. The next two terms, if I minus 5 from negative 4, I will get negative 9. And if I minus 5 from negative 9, I will get negative 14. So again, I just continued the pattern. Negative 4 minus 5 more gave us negative 9. And then if I minus 5 more, I get negative 14. Part B, the pattern, it looks like it is adding 8 every time. So since it's a positive 8, I don't have to write plus 8. It's just a positive 8. That's the common difference. The next two terms, if I were to add 8 to 37, that should give me 45. And then if I add 8 to 45, I should get 53. The last one, it's jumping quite a good distance. If I can't see the difference, I can work backwards and try and find out how much it went down each time. So I see that 44 minus 72 tells me it's going down 28 every time. 16 minus 4 confirms that. It's going down minus 28 each time. So if I continue that pattern, negative 68 minus 28 gives me negative 96. And then negative 96 minus 28 gives me a negative 124. Question number 2, you're determining whether each sequence is arithmetic. So not only does it have to have a pattern, the pattern has to be changing by addition or subtraction each time. So if I look at option 1, from 52 to 40, and then from 40 to 28, and then 28 to 16, if I don't automatically see a pattern, I can work backwards and subtract to see if there is a common difference. So I can do 16 minus 28 and see what that is, 28 minus 40, see what that is, and 40 minus 52 and see what that is. So 16 minus 28 is negative 12. 28 minus 40 is also negative 12. And 40 minus 52 is negative 12. So it's going down 12 every time. It has a constant pattern that's going through the entire thing. And it is by subtraction. So yes, it is an arithmetic sequence. Okay, so number 2, I've got 1/4, 3/4, 5/4, 7/4, 9/4. So they all have a common denominator. So really I can focus in on the numerators and see if we were just adding fractions with like denominators, if this comes out to be a pattern. So I go from 1 to 3, which is plus 2, 3 to 5, which is plus 2, 5 to 7, which is plus 2, and 7 to 9, which is plus 2. So it looks like it's adding 2/4 each time. Technically that reduces to 1/2, but it does have a constant rate of change, a constant common difference, so it is arithmetic. So my next one, 2 to 4, 4 to 8, 8 to 16, 16 to 32. Well, many of us probably already see what's happening, but again, if we didn't, we could do what I said and work backwards and check. 32 minus 16, 16 minus 8. Well, 32 minus 16, that's 16. 16 minus 8, that's 8. Already I have two numbers, two differences that are not the same. So it is not an arithmetic sequence. So the last one here, right off the bat, you can probably see that it is adding 0.4 every time, and so it is an arithmetic sequence. So question number 3 says, a theater has 50 seats on the front row. There are 4 additional seats in each of the following rows. Part A, write a rule to represent the number of seats in any given row as an explicit formula. So a sub 1, our first number in the pattern, would be 50, and 4, adding 4 each time, would be our common difference. And if we want to write the explicit formula, we know that was a sub n equals the first term, a sub 1, plus d, the common difference, times n minus 1. So we needed to know what the first term was and the common difference just to write the rule, the formula. So there's already an a sub n here. I just need to plug in the right side. So a sub 1 was 50. D, the common difference, was 4. And the n minus 1 is going to stay n minus 1 because I don't know what position number, what term number they want me to look for yet. Part B, when they ask how many seats are in the 20th row, I'm assuming that's what they meant. So we're going to plug 20 in for our formula. We're going to find a sub 20 by substituting in 20 wherever I see an n. So 20 minus 1 would give us 19. We would do 4 times 19. That would give us 76. And then 76 plus 50 would give us 126. So there are 126 seats in the 20th row. Question 4, JWA Weather Radio 103.5 in Jacksonville, Florida gives local weather updates every 18 minutes. The first update is at 2 o'clock p.m. You turn on the radio at 5:30 p.m. How long will you have to wait for the next local weather update? Okay, so this one is technically able to be modeled by an arithmetic sequence, but I'm willing to bet that many of you probably just tried it a different way, and that's totally fine. For example, when I first think of this problem, I'm just trying to think how many minutes passed already from 2 o'clock to 5:30. So from 2 to 5 is already 3 hours, and there's another half hour. So 3.5 times 60 is going to tell me how many minutes have passed. So 3.5 times 60 gives you 210. So 210 minutes have passed, and this update is happening every 18 minutes. So if I divide 210 by 18, I'll see how many updates have already happened. So there's approximately 11.67 updates that have already happened. So I'm still waiting for the 12th update. So to find out at how many minutes the 12th update is going to happen, I can take 18 and multiply it by 12 and see how many more minutes is it going to be before this next update happens. So 18 times 12 tells me at 216 minutes is when the next update is going to happen. Well, it's already been 210 minutes. So if it's already been 210 and the next update is at 216 minutes, then I have 6 minutes to wait. The next question is a little similar. The alternate way to look at this is you could have it just extended the pattern, which could have taken a good little while. You would say the first update happened at 0 minutes, which is basically 2 o'clock. The next update happened 18 minutes later, 2:18. The next update happened at 36 minutes later, 2:36, and then you could just continue the pattern from there until you figure out how many numbers you have to keep going in the sequence to actually get to the very next time it is going to update. Another way you could have looked at it is just kind of add an 18 as many times until you get to that, and then seeing how much further you have to go. So there are many ways to do this particular problem. The first way is the way that I prefer to do it. I feel like it gets us there faster. Again, I just said how much time had passed, 210. Well, if it's happening every 18 minutes, I divided by the common difference, the pattern of 18, which told me 11.67 of them have already happened. And I'm trying to figure out when the next one's going to happen. That's going to happen at the 12th update. And so 12 times 18 minutes each time gives me a total of 216 minutes after 2 o'clock is when the next update's going to happen. Well, if 210 minutes have already passed, then there's only 6 minutes left. Okay, so the very next problem. This is the first term of an arithmetic sequence is 5, and the 11th term is 125. So we discussed today how the term position, the term number, is like an x value, and the actual term itself is like a y value. So the first term is 5, and the 11th term is 125. What's the common difference? Well, common difference is just another way to think of rate of change, because arithmetic sequences are just similar to linear functions. So I can find it by using the rate of change formula we just covered in our last unit. I would do 125 minus 5 over 11 minus 1. So leaves us with 120 over 10. So 12 over 1, so the common difference is 12. It's a positive 12. So question 6, the city buses that run in your neighborhood stop every 12 minutes. The first bus arrives at 5 o'clock in the morning for passengers, and you get to a bus stop at 8:37. How long will you have to wait? Again, this is a reasoning problem. So this is a pattern, it is a sequence. It is going up every 12 minutes. Since they're trying to trick us with all of this time and minutes and converting, I find it best to just reason with the problem and use an answer and use a method that makes sense mathematically, multiple options. So I know from 5 o'clock a.m. to 8:37 a.m. I can find out how many minutes have already passed. So 5 to 8, 5, 6, 7, 8, that's already 3 hours. So 3 hours is 180 minutes, but then there's another 37 minutes on top of that. So a total of 217 minutes have passed from 5 to 8:37 a.m. So we have 217 minutes that have passed. And if a bus comes every 12 minutes, if that's the common difference, I'm going to see how many buses have already passed. So 217 divided by 12. So I get approximately 18.083 keeps going. That's kind of irrelevant. I just know 18 times it's already passed. I'm waiting for the 19th time it's going to come around. So I'm going to do 19 times 12 to find the 19th time that bus should come by. And that's going to come by at 228 minutes after the first time. So 228 minus 217 gives me a difference. 228 minus 217 tells me that I still have 11 minutes to wait for the next bus. Question 7. Faisal, not sure. This person is conditioning all winter to prepare for his college's hockey team tryouts. He's incorporating barbell deadlifts into his daily workout regimen. He plans to start with 2 reps, and every day will complete 2 more reps than the day before. So first scenario is he's starting with 2, and he's planning on going up 2 every day. So part A says write an explicit formula that can be used to find the number of reps lifted on any day. Okay, so if he goes with this plan, A sub 1, his initial amount of reps is 2, and he plans on increasing 2 every day. So that would be our common difference. Now I didn't ask about any particular number of days yet. We were just writing the formula to find how many he would lift on any given day if that was his plans. Part B, they switch it up a little bit. It says if he starts with 3 reps on the first day instead of 2, how many reps will he do on the 7th day? So assuming he's still keeping the goal of doing 2 more reps each day. So if he starts this time and he's doing 3 on the first day, and then he does 2 more each day, this would be the formula I would have to use, not the one we wrote earlier, the new one based upon him starting out with 3 reps. How many will he do on the 7th day? Well, 7 is going to be the term number we're trying to find, so A sub 7 equals 3 plus 2 times 7 minus 1. So that's 2 times 6, which is 12, and 12 plus 3 gives us an answer of 15. So he will be doing 15 on the 7th day. All right, the very last question did not count against you. It was a challenge question. It says Lisa sends an email to 5 friends. The next day, each of Lisa's friends forwards the email to 5 more people. The process continues for a few days. Which function represents the number of people who received the email on the nth day? So this question is put in there to see if you can kind of step back out of just doing the same type of problem over and over and over again and really realize what is happening as far as how this sequence or this pattern would be growing. So if Lisa told or emailed 5 friends, and then those 5 friends email 5 more friends, and then those 5 friends email 5 more friends, I am not just adding a constant amount every day. It is actually changing that number of 5 is being raised exponentially to a new exponent every time it is shared. And so this is actually an exponential function. It's something that's going to grow much faster than a linear function. Then if I just told one person and that person told another person and that person told one more person, that would just be going up like 1 every time. But if each new person that is reached out to tells 5 more people, and then that one person tells 5 more people, and it's just going to grow much faster. So therefore, the one that would represent the way this one is growing is actually answer choice B, which is saying that we could find this out by the common ratio, which is what we're going to call it when we get to geometric sequences, raised to the nth power. So this is something that we haven't talked about. It was a challenge on purpose to see if you would just kind of step back of being conditioned and trying to make it fit and see if you could reason with at least that it was much different than anything we had seen. So this is just a different type of sequence than the one that we are currently working on.